Okay, well, welcome everyone to this meeting of the virtual IMS user group. Thank you for joining us. I'm Trevor Eddles. I'm CEO of iTechEd Limited. We're a mainframe consultancy, analysis and technical authoring organisation. And we're responsible for the content on the virtual IMS website, and we produce the newsletters, etc. And you may be interested that we also look after the virtual CICS user group. Okay, let's run through the agenda for this meeting. As usual, most of the meeting will be taken up with a presentation, and today our guest presenter is Gary Euler. He's a consultant at Maintegrity Inc. And we also have Saurette, who is VP Business Development at Maintegrity. And their talk is called Providing System Integrity for Multiple LPARs with Improved GDPR and PCI DSS Compliance. A copy of the slides from this presentation will be on our website later today. Sometimes it takes a little bit longer. WebEx seems to be getting slightly slower with producing a recording of this session, but it will be there. And if you missed any of our previous meetings, you can download copies of the presentations from our website. You can find it on the resources page. So at the moment we're on fundy.com/virtual IMS, and that's all one word, virtual IMS. Following Gary and Al's presentation and any questions you have for them, we'll move on to the latest IMS news and latest IMS related articles. Feedback request is there to remind me to ask you for your feedback about this virtual meeting, and then I'll give you the dates and times for the future. So that's the plan for this meeting, and I'm anticipating that it's going to last for just under an hour. Okay, as I said, today's presentation is from Gary Euler and Saurette. Gary, during his over 35 years in the IT industry, has held senior management positions in a variety of IT companies that were engaged in both software development and IT services. Gary has held senior positions as a technician, including as an IMS systems programmer, as a senior manager in IT delivery, and in a variety of business development roles. So Gary and Al, I'd like to thank you very much for being with us today. And what I'm going to do now is pass control of the meeting over to you. So let me do that now. Gary, I'm making you the presenter again.
Okay. Did you see my slide? No. Let's see here, share screen.
Oh, there we are. It's just coming.
Ah, okay. Here is this. Oh, here. Sorry about this. Okay, I think we're ready to go now. Welcome. I'd like to thank Trevor Eddles for giving us this opportunity to present our FIM Plus product to you today, and thanks for listening. My name is Gary Euler, and along with my colleague Saurette, we're going to talk about our company's ZOS file integrity monitoring product, FIM Plus. At the end of this, we hope you'll know what the product does and what you can use it for. Typically, I don't sound this bad. I do have a bad cold, and I apologize for that, but the show must go on. If you do have any kind of a question, you can use the Q&A thing on the side of the WebEx, and Trevor's going to interrupt us and answer them in stream, which is a good thing to do, I think. Just to give you a little bit of a background on what we're going to do today. Today, we're going to talk a little bit about where Maintegrity came from. My co-presenter, Al, is going to talk about what the business needs are for the product and what problems FIM Plus solves. I'm going to go over how FIM Plus can be used to enhance your security posture and talk about how it can be used to verify that your applications are installed correctly and remain correct over time. Finally, I will discuss with you how you can interact with FIM Plus and show you some of the capabilities included with our GUI. The principals behind the company have been involved in enterprise software since the late 80s. Some of the products they've been involved in include Harbor, Standalone Environment, and ISPW. In the 2014 timeframe, one of the key developers in the company, Paul Scott, was working for a company called Benchmark Technologies. Some of you might be familiar with their product called ISPW. ISPW is a developer workbench implementation tool primarily for mainframe applications. Paul, who's kind of a serious programmer, thought it would be a useful thing to have a mechanism to validate that what was being rolled out in new application releases was what was actually intended to be rolled out. On his own time, he started working on a tool to do that and continued along for a few years more or less as a hobby project. Paul continued to develop the product on his own time with an eye to selling the technology or building a business for it somewhere down the line. Now, in January 2017, Al Saurette and Paul became aware that FIM technology was going to become a requirement in the 3.2 version of the payment card industry's data security standard. Since mainframes still process the majority of credit card transactions in the world, they decided to form a new company, Maintegrity, to position the code that Paul built to meet the PCI DSS requirement, as well as meet the original DevOps need. Since 2017, Maintegrity has taken the product up the value chain by providing more than just change detection. Now have the capability to deliver a significant amount of forensic data and interface to most of the program products existing in the mainframe ecosystem. So FRM Plus started out as a DevOps tool to validate and monitor software implementations and became a security tool to meet security compliance requirements. Though there's a lot of overlap in meeting both of these needs, there are features aimed at each of these needs individually. We'll go over both aspects of the product in some detail today. A little over a year ago, the company completed an initial round of financing and remains well financed to this day. You may think it's a tad unusual to have a mainframe software startup company in this day and age. I certainly did, and yet here I am. If you're trying to get compliant with PCI, FIM Plus directly addresses requirements 10.5 and 11.5 and provides significant strength for both GDPR and NIST. FIM Plus is not a system like RACF, ACF2, or Top Secret. It isn't designed to lock folks out of places they don't belong. Those systems do a great job on that, but what FIM Plus does is make sure that people who have proper credentials have not done anything to inadvertently or maliciously compromise your systems. Instead of keeping people out, we make sure that the people who are allowed in haven't done anything which can hurt you. On the DevOps side, FIM Plus can be used to determine that the same version of code exists on all system images. This is true for both system software and applications. It can also be used to make sure that what was implemented is what was intended to be implemented and continues to be what is implemented. Every FIM Plus scan produces an audit record whether the scan was successful or completed with detected changes. If you've ever had an auditor ask you whether or not what is running is what is supposed to be running, with FIM Plus you can answer that question in seconds and provide a concrete audit trail proving it. Finally, and perhaps most importantly, FIM Plus can give a new generation of support staff, perhaps intimidated or unfamiliar with mainframes, a window into the status of mainframe systems and applications via a familiar GUI interface. Something goes wrong, FIM Plus quickly gathers up the who, what, where, when information and presents this information in a very familiar fashion. We'll go over all these capabilities in the next 30 to 40 minutes. Now I'm going to pass the baton to Al to provide some information on what the business needs are for the FIM technology. Al?
Gary, thanks very much. I am very interested in the security aspect of mainframes. Certainly, over the years, security has been a key element of why the mainframe continues to be successful today. And what we're trying to put forward is an ability to use that capability in a number of different ways to focus on internal security, those people that are already on the inside of your security firewalls and access control tools. As we started to look at this problem, we ran across a report funded by IBM from the Ponemon Institute. They did some very significant sampling over the last 5 years, and the most recent numbers are here on this screen. So in our environment, I think it's important to understand that detection in the mainframe or Unix or Linux or any of the other platforms, a very slow process. 206 days to discover problems in this environment that were active for all that length of time. A big contributor to that is that most of the access control tools that try to identify malicious activity or accidental activity for that matter are unable to do anything except identify suspicious actions. FIM Plus, on the other hand, actually goes in and says, has the content changed? Is it in its trusted state? So it's a little bit different from a detection standpoint. And when we get to the response and recovery capability, a further 73 days is required for that. Well, often enough, we think that detection takes place in the credit card companies, where they actually phone a company up and say, we have a pattern of fraud that looks suspicious, and it appears to be coming from your environment. But even once that happens, then just kind of getting all of the information required and identifying what to do about it and getting the right stuff back in place requires a further 73 days. I'm going to spend a couple seconds on the root cause. When they were doing surveying, you have to remember that they were only looking at companies who had encountered data breaches. In that particular case, malicious attack was 51%. So when we classically think of an outsider breaking in, 51% or 250 breaches, basically speaking, occurred as the result of a malicious attack. However, there are two other big areas of problem, and that's human error. So I make a change, and that change causes a problem which perhaps breaks security or causes some sort of revelation of internal information, or makes it available in some manner in a dump or whatever, that it gets revealed to outsiders. And that's the result of somebody making a mistake. Then there are things that they call system glitches. Perhaps a file gets corrupted. Perhaps there were some bad configs when the product was originally installed. Perhaps they didn't change some basic passwords. So this is not the result of somebody making a change, some legitimate person going in to make a logical change. This is actually everything that is not caused by a human that is accidental in nature. But you can note here that 25 plus 24%, 49% of even the data breaches were caused by some type of activity which was accidental in nature and perpetrated by insiders. Gary, if you could move that up a bit, or go to the next slide. Yep, thanks. As Gary said, we've been managing with access control tools like RACF, TSS, ACF2, and firewalls for a long time. And the basic premise is let the good guys in, keep the bad guys out. And that worked really well for quite a period of time. However, what we focus on with FIM Plus is insiders and people that get inside the walls. And they come in three basic types. One, malicious people outside are getting more resourceful. So they go out there with phishing or man-in-the-middle sort of activities and steal credentials. And then they go from being an outsider to being an insider. The next group is staff that you hired that are really solid citizens, but for some personal reason, whether it be addiction or a financial problem or a health problem or a marital problem, they go rogue. They need to find a way to access more money or finance or something. So they actually become malicious attackers, but they're already inside because they already have legitimate credentials. And even more important, or probably more dangerous, is they know where to attack. And then the third group really is well-meaning staff, people just doing their job, but they're doing a deploy, they're doing an update, they're making changes to applications, they're making changes to system parameters, but they're making mistakes. And I think if you go back and say there were 250 incidences where the mistake that they made actually caused internal information to be exposed, I think there are thousands of times as many mistakes actually going on that would either impact ongoing performance, perhaps they don't get the right level of the rate table implemented and they have incorrect output after making the change. Those kinds of things can be just as devastating as a data release. So what we try to do with FIM Plus and what it is really good at doing is determining if your test environment, your trusted environment, which Gary will refer to later on as the baseline, we take a copy of that, we use a hashing algorithm, we capture the essence of it, and then we actually make comparisons. So we can tell if all of the changes were implemented correctly on the way from QA to production, for instance. Or did somebody come in and interrupt the deployment in step 18 and forget to do step 19? So maybe something that was supposed to be implemented didn't get there. That's one of the kinds of problems that FIM Plus is really good at resolving. In a multiple LPAR environment, this becomes, of course, much more complicated. Was I pointed at the right LPAR? Did I update the right environment? So the verification process that's implicit in FIM Plus allows you to go from LPAR to LPAR and say, are the things that are in production exactly the ones that are supposed to be in production and nothing more and nothing less? However, as we go across LPARs, there are actually things that are supposed to be different. Like, for instance, in your configuration environment, you might have certain exceptions like the name of the partition that you're running in. So we allow both. We can understand what should be the same and ensure that it's the same. We also look at exceptions and say, okay, once those have been changed and they're in their production version, they shouldn't change anymore. But as you go LPAR to LPAR, they may be different. So traditional monitoring has been manual and very labor intensive in this environment, and it requires a lot of ZOS specific skills. So we started out to try and build a product that dealt with all of those, and I think we've been somewhat successful in that. So Gary, if you take me to the next slide. Exactly what is file integrity monitoring? At its very core, we take a trusted copy of a whole application or a whole system image, and we create hash codes for every component on it so that we know every single component that is a part of that system, and we have the essence or a digital fingerprint, if you like, of what that code is supposed to look like. Save that key in our encrypted vault, and later we can go back and run another scan, create a new set of hash keys, and compare the new hash keys with the hash keys that are in the vault. If both of those pictures are the same, we say things are good. If they're different, then we raise an alert. So as we go through this, you'll see, and Gary will talk a little bit more about what we protect. But we protect ZOS, the ZOS system itself. So we can identify right from the time when you get your SMP input from IBM that the right modules are being used all the way through the process. So into the test environment, into the sandbox, into production 1, into production 10, into production 40. Same thing is true for CICS, IMS, DB2, TCP/IP, and other critical subsystems. So all of this can be done and the information can be solicited automatically. In the application world, we can do the same thing for executables, for JCL that runs production systems, for configuration numbers. If you have a USS environment that most people have these days, we can also check all the scripts, all the CLIS, all of the log files associated with SMF, make sure that once they're written out permanently that they haven't changed. We can even work with encrypted data sets without having to decrypt them. So kind of a broad range of almost everything that you will find in the mainframe environment. If we find a problem, we raise an alert. That alert can be sent by text or email directly to admin staff, or it can be forwarded to a central console like QRadar or Splunk or any of the standard security products. In addition to that, very importantly, is we can act on the alert. So we can, with 4 clicks, I will show you later how we can drill down, provide all of the forensic information in an actionable format, and then move on to being able to do the restore. So we're not only working on the 206 days it took to detect a problem, we're going to give you a solution that's going to work on the 73 days that it took to recover. But one of the questions that we typically get is how much overhead is associated with this. Because we offload all of the heavy processing around hash key creation, since we offload that to the crypto cards that are now installed in almost every mainframe, there's actually minimal CPU used in the process. So we would like to say that you can scan on a weekly basis if you want, you can scan on a daily basis if you want, or for critical applications, you might decide you want to scan every 10 minutes or every hour. All of that is quite possible with the existing product because it's so efficient. Gary, I think we're going back to you at this point, and you can lead them through exactly how this works.
Yes, again, thanks, Al. An overview, pictorial overview, a build out of how FIM Plus works. This model is using a baseline model. You don't have to use a baseline, but it's probably the most common model that we see used. In the example, like Al said, we support all ZOS files. You can see PDS, PDSE, log files, sequential files, all the Unix file system, the USS files, they're all supported. While this may be obvious, I just want to note that data files, including database files, which change continuously as a matter of course, are not good candidates for FIM Plus. FIM Plus is about detecting changes in files that should not change, and so if files change all the time, they're probably not something you want to use FIM Plus for. FIM Plus is implemented using a client-server model. We call the server the trust server. This component receives trust keys from an agent and either stores those keys in the trust vault or compares new keys to keys already stored in the vault. My component is called the agent. Each LPAR would typically have its own agent. The agent creates the trust keys, sends them to the trust server, and the trust server takes those initial set of keys and puts them in the vault. This initial scan will establish the baseline for that group of files or application on that LPAR. A log record is created as a result of every scan, including scans that did not detect any changes. This provides an ongoing audit log for your system. Depending on how your organization wants these to be handled, you could also pop them into a SIEM product like Splunk or QRadar. The plumbing exists to do that out of the box. After the initial scan is done, on an ongoing basis. You rescan these files, you send the keys up, you compare them, and you continue to propagate, validate success records, so you build an audit trail of all of the successful times you've done a scan, as well as any that are unsuccessful. When you do detect a change, like in this example here, MEM2A has been altered. The process is the same. The keys go up to the file server. The file server compares them to what's in the vault. You'll get a failure. And then what happens, Al mentioned this in his thing, you can do different actions. In order to engage the responders who you want to respond to this validation failure, you can either email them, you can text them, you could pop a operator command up on the console, that kind of thing. You can do just about anything you want. Key thing to note here is over here on T0 and T1. When Al was talking to you about the Ponemon report, he mentioned that it takes 206 days, I think, and that's almost 7 months to detect a change, or in what the Ponemon study found. Well, here, what we've done is we know now that this file M2A has changed in the time interval between T0 and T1. That's a significant piece of forensic information. Now, without any additional effort, we know that something's changed within this time interval, and we know what's changed. Now, if you think it would be a good idea to take that information and go into SMF and get the SMF records to see anybody who's changed that in that time interval, would be a good idea. Well, it is, and that's exactly what we do. So now, you know, typically, Al talked a little bit about scanning. I'll tell you a bit about this. We do support quick scans and full scans, and we recommend you do run quick scans throughout the day, and I'll tell you what the difference is in a minute. But if you run quick scans, say every 3 hours, you will have detected that this file changed in less than 3 hours, because the interval between T0 and T1 is 3 hours. That's quite a difference from almost 7 months. Now, just a word on trust keys. Trust keys that we use in the system are two-part. There's a part that we scan and we create a hash code from the metadata of the file, and there's a component there we scan the contents of the file. When we do a quick scan, all we do is we rescan the metadata of the file and send that up for comparison. When we do a full scan, we do both components. Now, a quick scan will catch most of the problems. The things that won't catch are things that when people do update and place things like super zap, I don't think people use that very often anymore, TSO test, those kinds of utilities. PDSEs, interestingly enough, if you do a super zap on a PDSE file, it does change some stuff, and you will detect it on a quick scan. The idea is that quick scans, because they take so little effort, you run them periodically throughout the day, and you run a full scan, which is more IO intensive, more in a lower utilization period like at night. As you should have seen, FIM Plus does validate that your files are in a desired state. We can detect all the changes that are made and raise alerts on them. You contrast that with other tools that rely on scanning SMF records to check accesses. FIM Plus is better because it actually reads the metadata and the contents of the files and verifies that they are in. When using tools which scan SMF records to detect changes, it's easy to overlook changes made by a valid user ID, even though the user's credentials may have been compromised. FIM Plus, you know the code is at the correct version. It's a more positive way to validate your apps. One of the things we've done with the product is we've taken a serious approach to reducing false positives. FIM Plus, when a change is detected, FIM Plus will check to see if a change management record exists in your change management system. And if a record does exist, it can take a different set of actions than if a change record doesn't exist. We are integrated with a variety of third-party change control systems like ServiceNow and ChangeMan. Now, having the ability to take a different set of actions provides users with a powerful mechanism they can use to tailor a response to specific types of incidents. You probably want to do something different if you've detected a change that was supposed to happen than if you detected a change that wasn't supposed to happen. And as we discussed previously, there are DevOps features built into the product that help you with application and system software rollouts, as well as making sure they stay in the desired state over time. For LPARs, there's a feature called LPAR synchronization. This helps clients keep multiple LPARs running the same versions of files. El talked a little bit about that in his talk. We're going to go in a little bit more detail in the next few slides on how FIM Plus can verify large-scale application and system rollouts are implemented correctly and stay in that state. When you're rolling out software and applications across multiple LPARs, it can be difficult to make sure that all the modules have been rolled out correctly. In addition, some files will need to be specific to each LPAR. El talked about that a little bit. System and applications, no matter our best intentions, seem to drift away from accepted code base levels over time. People will put an emergency patch on one LPAR and forget that it may need to be rolled out to the entire complex, that kind of thing. I don't know if any of you have ever been in a situation where you have a problem in one LPAR but not others, and then the search is on for what is different. I know I have. Again, in a non-FIM environment, auditing your production code is in the correct state is time consuming. You'd have a process that checks that files haven't been modified. And even then, these solutions will not check that code has been updated in place using a tool like SuperZap. With FIM Plus, it's quite simple to establish a version as a baseline and then compare every other copy of the system, whether they're running on this LPAR or another LPAR, to that baseline. Scans will detect any deviations from the baseline. Whenever changes are detected, proper people will get notified because the situation has been discovered. Determining a response is a much more straightforward task. The result is continuously audited systems complete with ongoing audit records that show your systems are correct. Your applications and systems will be completely protected from accidental or malicious changes. The result is you'll be running systems that you know are correct and that you can prove to any auditor that are correct. I'll show you some of the forensics in a couple of slides. This picture shows how this is set up for an application. If you have applications, typically they'll come out of some kind of a QA process prior to being implemented. In our terminology, we've called this a gold version. You can call it whatever you want. It's whatever your post-QA version is. The first step of this process, which isn't on the slide, you define this new version to FIM Plus, assign a release number to it. Next, the post-QA version, the gold version, is scanned by FIM Plus, and the trust keys, the hash codes, are put into the trust key vault under the release number that you just created for it. Next, you take your files and you put them out into the LPARs that you have. As a final step in the rollout, you can initiate a scan of the application, compare the keys from the gold version to the keys that you've downloaded, and verify that your application has been installed correctly. Subsequent to that, you can set up so that the scans will run periodically so you can see that it'll stay in the same state. Any LPAR that's talking to the trust server does need a TCP/IP connection, and because it just needs a TCP/IP connection, it can reside on the same CPU or a different CPU. Some of the features in FIM Plus were implemented specifically for maintaining application and system integrity. Certainly the whole baselining thing is aimed at maintaining integrity across LPARs and that kind of stuff. The forensic stuff that we put in the product was really put in as a result of wanting to meet the security aspects of the product, but they do have a lot of utility in the DevOps space as well. Being able to tell when things have changed and then figure out why they've changed is very, very useful. Pardon me. There are some files that are going to need to be different on different LPARs. These files will need to be scanned to make sure they have not changed on a specific LPAR, but they must be different than the baseline gold version. This could be for LPAR specific parm lib that Al mentioned earlier, or something that needs to be unique on every LPAR. FIM Plus has all the capability built in the product to be able to do that. In addition, we can support all the log file types you can imagine. Log files, when they're active, should change all the time, but after they're inactive, they should never change. And we have complete support for all of that built into the product. We put a lot of usability features into the product as well. Just so you know, FIM Plus has, a lot of the kind of interfaces you might expect for a mainframe product. There's a GUI, there's ISPF, there's a batch interface. There's also a complete REST API, so you can programmatically invoke just about any function in the product. You can turn on auto discovery, and I don't know why you wouldn't do that, but auto discovery will monitor all your APF libraries. It'll monitor libraries contained in started tasks. The started task libraries are joined or are discovered after they've gone through JES, so any started task proc symbolic substitution will have already taken place. Even libraries that you add to the system, if you add an APF library via auto command, FIM Plus will detect that and add it to the watch list. FIM Plus is designed to run 24/7. Almost everything, the system has to be up for everything except for two things. If you change the underlying software that FIM Plus is running, you need to shut the system down. And the other thing that you need to shut the system down for is if the TCP/IP address changes, but those are the only two things. We put in a lot of, out of the box it comes in and supports a lot of third-party software products, but the system is designed to integrate with your operational ecosystem. We've mentioned already we do support SIEM products like Splunk and QRadar. We support change management products, and we're adding more all the time. And we don't think if you have something that we don't support, we don't think it's a big job really to add support for another tool, as long as it has an API. It has to have an API. Also in the product, there is the pardon me, my throat's going. There's the capability to initiate scans at predetermined times or on demand. You don't have to do that. You can use your own scheduling tool to schedule the scans if you want, but in the product there is the capability to do that kind of thing. As well, we have this complete forensic information gathering and presentation capability. Well, with that, I'm going to probably turn it over to Al so he can show you what features are in the GUI and kind of show you how pull all of this together somehow. Al?
Perfect. Thanks, Gary. I think it's really important to understand that FIM Plus gives you visibility into the running system that you have in the environment today. So you can really peer inside the LPARs, understand exactly what is running in production, compare that automatically to the gold system or to the trusted system in the vault. Those things are really important for near instantaneous discovery of problems, even that are buried deeply underneath by a very knowledgeable hacker. But in the case of accidental problems, they come up right away. So the support that they give for the deploy team. So, the applications guys throw a new app over the wall and the operations guys get to implement it at 2 o'clock on Sunday morning. Well, by the time that change window ends, wouldn't you like to know that application was completely correct and contained all the components and nothing more than the ones that came out of QA that had been rigorously tested? It certainly saves a whole lot of finger pointing. But one of the things that I think is really important is how we interface to human beings. So at the end of the day, we want to enable people to work faster, to be able to save time, to be able to do things that they haven't done before. But every single one of these functions is designed by operations folks, which we typically have been over the years, to complement how you would typically do the work and make sure that errors that crop up in a process are caught early enough that they don't cause an outage, that they don't cause a problem for you. So if we just go into validation, one of the key elements that we talk about is not being confused by red herrings or false alarms. Most of the access control tools provide logs, and I mean SMF is one of the places where all that stuff gets logged. But if I'm just tracking accesses, often enough a malicious activity can look suspicious, but it might not, because again, people are using legitimate credentials. So is it easy to spot them? Well, no, it isn't if I'm just looking at access records. So what I need to do is A, be able to determine all the changes, and then B, screen out the ones that are a false alarm. And we do that by going to the change control system to see if there was a change that was supposed to take place at that time. Or we'll go to SMF and see how the user, what user IDs were active. Those kinds of things that we do automatically within the FIM Plus product. But I think in this next little section, you'll see something that's completely different. So let's just assume we've been scanning away for a couple of months and everything's been perfect. And then suddenly we get an alert. Well, an email text can be sent directly from FIM Plus to the admin team at the same time as we're alerting through the usual management alerting process. And that could be your single pane of glass that shows everything going on in your system. Our intention at all times is that we provide information so quickly that by the time management is aware that there's a problem, technical folks already have all the forensic information about the problem to A, validate it's a real problem, B, identify where it came from, and C, start towards recovery. So if you think about the NIST framework for response management, it contains all of those elements. So FIM really implements all the pieces of that process to enable people to make the right decisions very quickly. So we get an alert. So we send out this alert message. Now, with one click on that alert message, I can bring up the FIM GUI. This is a stylized view of what that GUI looks like. But you can see, oh, well, I was scanning along very nicely for quite a while and everything was correct. But all of a sudden, I get this mismatch. Now, when I get a mismatch and I say, oh, something has changed, what's the first thing I want to know? Well, I can click on the item and it brings up right away, it brings up the SMF records that were associated with this. Here's a really important thing though. Since FIM Plus is the only tool in your working environment that knows when things were last successful, all I have to do in looking for SMF records is say, give me the SMF records that access that specific component between the time of the last good scan and right now when I just determined a problem. So in this particular case, you can see there were 3 updates. If I don't know when to start, well, now I have to go to SMF and I have to go back a long, long ways and hope that I can figure out where the heck that problem entered the system, whether it was accidental or on purpose, doesn't really matter. I have to look at a lot of data, perhaps thousands of accesses, to figure out which was the one that didn't match. If I only have to look at 3, in this particular case, it's an unknown user ID. Well, that might give me a clue that is some type of malicious activity or somebody that got in that wasn't supposed to. If I see it's, oh, one of the system support guys, well, maybe that's my ID. And I kind of go, oh yeah, okay, I know when I did that, laughed. Those kinds of things are really important in very quickly identifying, is it a problem or is it not a problem? The next click, so that's one click, and I have all the relevant SMF information. Another click fetches me all the change control information. In the particular version where that we were running when we built these screens, the ServiceNow instance was running in the cloud. So when we clicked to get the information for that specific component in within the application that's running, we can look at the ServiceNow configuration information and say, what application was that, and was that supposed to have been updated during the interval in which the change took place? So again, more relevance. Is this an accidental change? Is this a malicious change? Or is it a false alarm? So if it's a false alarm, we can immediately downgrade that because we know that it was during an authorized window. So one more click, well, there, and we can say, okay, I know the component that changed. Show me what the actual change was. So if I've got a text component like a configuration number, or I've got lots of other information like JCL and that sort of thing that are visible to a human, we just invoke on the fly a compare product. And the compare product will come back and color code what the differences are. So as a result of getting the alert, 3 clicks later, I know exactly what was different in that configuration member from one side to the other. In our sample case here, we're saying a TCP/IP port definition was changed, and it went from New York to Russia. Would you think that was a problem? I suppose you might. In addition to that, I mean, you can also disqualify things. So at the end of the day, you can say, oh man, it was just a comment line change that somebody put in. It doesn't make any difference. So, I'm not worried about that change in the slightest. Then one more click, and we can see how we actually start moving into recovery. So one of the new tools that you'll see next year is our recovery assistant. Because we know when the problem started, because that's the success record that was written to the file, we know when that started. We know when to restore the system to. Because we know the components in the system, we can select all of the components that changed, and only the ones that changed, and restore them. But much more importantly, in that automated restore process, we can actually then go in, after the restores have been done, we can go in and verify that they were all done correctly, and the system now matches exactly what we wanted to have, our trusted system. That way, when I come back on the air, I can stay on the air. I don't have to worry about, did I get everything? Did I restore everything? Was there something else? Did I restore too much? Did I get it on the right date? No, the system gives you that kind of information. FIM Plus provides tailored JCL that you can just simply run to do those restores. And it can come from a place like HSM, or it come off your backup tapes or application backup, that sort of thing. But that can all be done automatically. So we think that has the, if you'd go to the next slide there, Gary. So what's the result of all that automation? Well, we have advanced detection. We can tell everything that changed. Typically, you have basic detection, and you're sort of guessing as to whether a suspicious activity is really a bad thing or not. So my question is, when I'm working through this, I'm probably working through it in a manual process because there aren't really any tools that automate that in any great deal. My first question is it a false alarm? Well, we talked about the integration with change control, the ability to look at the lines that changed. I can pretty much determine whether this is a false alarm pretty quickly or not. If I'm looking at the change control information, I can see why the change was done. So if I then go in there and look at which lines changed, I say, oh, well, does that seem to be a good idea with respect to what the objective of the change was? Is it relevant or not? I right away know the scope of the problem. What was affected? I know every component that was affected. I know every application system, every system image that was affected because I'm scanning on a global sort of level. So what was affected? When you start analyzing a problem from access control information, you know perhaps what the entry point was, but most typical hackers would now move from the entry point to other modules in the areas, and it may be very hard to trace once they've got some level of control. So knowing every single component that was affected, pretty important. So that's a real difference. And I always like to say, you know, all of a sudden I've got myself a first-class problem here. First of all, I want to know, is it a real problem? If it isn't, I want to get rid of it. And when my boss phones me, I want to say, no, I already looked at it, disqualified. You know, it's this kind of red herring or this sort of issue came up. But when it's a real alert, time is critical. So do I want to go spend 73 days going through this whole corrective action process? Or do I want to go over here and have the system do that for me and be through that process in 4 or 5 or 6 or 7 clicks? It's the difference between reacting in minutes and probably taking weeks to know the scope of the whole problem and being able to react. So we think that the automated forensics is really important, and the integration with the other information sources is really important. So if you move on, Gary. So at the end of the day, here's the kind of things that we deal with. We don't want you to have to do a whole bunch of extra work. In fact, we'd like you to do less work because you're probably busy as heck already. Let's add some more work on top of that. Not really a good idea. So we discover the APF libraries. We discover the subsystem and the step lives and all of the information that's relevant to CICS or IMS or you know, any of the tools running at that level. And we can ensure that they're all at the right level. We also understand application components. So if you have us enabled through the DevOps process, we can right off the bat verify that the deployment went okay. But in addition to that, we'll know all the application components so we can monitor those automatically. We're saying, since it's a learning system, we say, you know, have it done automatically once, and then have it done automatically every time FIM Plus runs. So we can verify software configs are correct right from the get-go. So in the new year, you will see an SMPE capability from us, and it will actually read the SMPE database, and it will highlight any things that have ever gotten into your system that aren't specified in SMPE. Now, again, like always, you'll be able to say, you know, I'm going to suppress the action on this member because it's there for a legitimate reason. But the notion that you can go from SMPE through the DLibs, verify that they were received correctly from IBM, verify that they are the ones that loaded APF libraries, verify that your target libraries are all correct. That's what we think is important in ensuring that your system remains operable. We can respond to incidents faster. I mean, that should be like ultra clear by this point. If not, we'd be happy to do a demonstration for you that makes it even clearer. Because we improve internal control, because we can identify internal threats, either accidental or malicious. We fit specific controls within PCI, the NIST structure, GDPR, but more importantly, we know that the security inside the walls is much stronger than it was previously. So you're scoring on all of those environments, whether it's PCI or NIST or even the general requirements of GDPR, has to be improved, and it has to be improved a lot. So we can prove that the content hasn't changed. We can present all of that relevant information in one GUI view. So anybody can start taking the right sort of actions because they have all the data required from various sources. So unlike where Forrester is worried about islands of automation within the computing ecostructure, we bring those silos, those islands together, share that information in a meaningful way, make it easy for people to access. And we think that that's a far better solution, both from a security standpoint and from a systems management standpoint. So I always like to say, everybody else hopes your modules and the rest of your data is correct. FIM proves it. So Gary, back to you.
Hi, that sort of concludes our formal presentation for the day. You know, thanks for listening in. We hope you found it informative. If you do ever want to have a presentation for your company or you want to do a trial, give us a call. I was wondering if there was any questions.
Trevor, did you end up having anything come in from the field?
No, not related to your presentations. So I'm just waiting to see whether anything actually comes through now. Otherwise,
well, we'll stay on the line here, Trevor. And if something comes in a minute or two, you can go through and you can just ask us in stream, and we'd be happy as heck to respond on that.
yes. Or if you can go back to your very first slide that had your email addresses on, then people could perhaps jot that down. Oh, here we go. I've got a question now. Okay, what does pricing look like? MIPS based, install based, etc. That's.
Sorry, was that a pricing question?
I want to know what the pricing is MIPS based. We actually have two different pricing models. You can either lease the product on a monthly basis, or you can buy it on a MIPS-based model and pay an annual maintenance fee. I think that answers the question, but if they want to know more, we'd certainly be interested in giving them both pricing options for their specific situation.
Okay. Yeah, well, that's what I was saying. If you can go back to your first slide with your email addresses on, then if people have got questions like that, they can get straight back to you.
We'll get there.
Okay, brilliant. Yes. I'll just leave that on screen for a second or two. Right. Well, thank you very much. Thanks, Gary. Thanks, Al. That was really interesting. Because we're a virtual user group, then can you assume that we're giving you a virtual round of applause for that presentation?
Trevor, from your standpoint, have you seen anything like this before? Is this kind of new? Do you think it would have been interesting to the group? You see it as useful?
I think so. I mean, I can't think of anything else, any other product that sort of works quite like that. So I hope members of the user group have found it useful.
Perfect. Thank you very much.
Okay, I'm going to make myself presenter now, so you'll get a message on screen perhaps, and share my point. Okay, yeah, thanks. I'm just going to run through the last few slides, last few things to tell people. So I usually talk about news when I can, but I haven't got any IMS related news, so we move on. Articles, there's how a CM1 SL0 input message sent to IMS Connect works. That's by Subhasish Asaka and that's on the Destination Z website. There's a link to all these articles on the virtual IMS user group website. There was also 5 IMS OTMA enhancements you don't want to miss. That was by Jack Yuan and Eric Su, and that was in IBM Systems magazine in November. And then the one that gets the longest title, IMS 15 Managed ACB Enhancement Option No Check to Import Defined Source Catalog. That was by Ken Nagayan, and that was on Z Systems Developer Community. That was in October. Like I say, links to all these articles are on our website. So, almost lastly, can I ask about feedback for this meeting? You can email your comments to me. My email address is on screen, or you can use the Contact Us webpage on our website. And if you've got any questions for Al or Gary, then you can email those to me and I'll pass them on. So it's trevor@iteched.com. Okay, meeting dates. Now you can see that's slightly different to normal. When Rocket Software took over sponsoring this user group from Fundy Software last year, we carried on as normal, but Rocket have decided that they don't wish to sponsor the user groups anymore, and that means we're looking for new sponsors in order for this virtual user group to continue. So we need someone to host the files, etc., for the website, and someone to provide access to WebEx or similar, so we can hold these meetings. So if you know anyone, and bear in mind I am talking to a number of companies at the moment about sponsorship, but if you know someone for whom this would be an ideal fit, then just get them to contact me. Again, trevor@iteched.com, and we can talk about it. Assuming that sponsorship all pans out, then our next meeting will be on the 4th of February next year. And of course, social media is very important. If you do anything on social media and talking about this user group, we're #virtualims. And of course, everyone likes likes. So if you're on Facebook, we're fb.com/virtualims. If you can like our Facebook page, follow us on Twitter, again, virtualims. And there's also a LinkedIn group. Of course, LinkedIn doesn't do vanity email addresses, so we're virtual-ims-user-group, and then some number that no one can ever remember. Okay, well, that's all for this meeting of the Virtual IMS User Group. Can I thank you all for attending? Thanks to Rocket Software, who have sponsored this user group for the past year. And as I said, if you know a company that would like to take over sponsorship, then please let me know. And of course, I'd particularly like to thank Gary and Al for today's presentation. So that's it. Thank you all very much for joining the meeting. Thank you for your support over the past 12 years, and hopefully this group will meet again in February. So thanks a lot, and goodbye.